Okay, so what we're going to be doing today is learning about the elimination method for solving equations. We're going to use elimination more for something like this. So we have 3x plus 2y equals 17. 7x minus 2y equals 33. And what we'll notice, the reason we're not going to use substitution with this is that this x is not alone, this y is not alone, this x is not alone, and this y is not alone. So we don't actually have anything we can isolate in a pretty way for that. So what we're actually going to do in this case is we're going to actually add up these equations. So what we're going to do is this line is going to be, we're going to be 1 plus 2. We're actually going to add the equations and we're going to see what happens. So 3x plus 7x is 10x. 2 plus minus 2 is actually 0y, which means 0y is really just 0, which means this variable has been, that's going to be kind of eliminated. 17 plus 33 is 50, so 10x plus 0 is just 10x. So 10x equals 50. Divide both sides by 10, and you get x equals 5. And then what we could do at this point is we can sub this into either equation. So what I could do is I could say sub this into there, so I could sub x equals 5 into equation 1, say. And I picked that kind of arbitrarily. 3x plus 2y equals 17. Instead of x, we're going to write 5 plus 2y equals 17. 15 plus 2y equals 17. I'm going to cheat a little bit and go up to there. So 2y equals 17, bring the 15 over. And you get minus 15. 2y equals 2. Divide both sides by 2. And you get y equals 1. And that's it. So therefore, the solution to the linear system is x is 5 and y is 1. Now, things were lined up pretty nicely there, so let's try it now when it's a little bit more tricky. So let's have our example 2. So we're going to have 4x plus 3y equals 34. 5x minus 2y equals 31. Okay. And we're going to add these up. So it's going to be 1 plus 2. And we get 4 plus 5 is 9x. 3 plus negative 2 is plus 1y. And add this together and we get 65. But there's a problem because nothing got eliminated. Nothing was eliminated. Right? Because the x is still there and the y is still there, and we still have two variables and we still can't solve this. And so elimination was a pretty epic failure there. So we're going to try it in a different way. So example 2, take 2. 4x plus 3y equals 34. 5x minus 2y equals 31. And we already know this is not going to work, right? Because if we add them up, nothing's going to get eliminated. But what we're going to do is we're going to actually multiply these equations to make stuff equal. So what happens is I want the 3 and the 2 to be equal to each other. It's kind of like finding a common denominator, right? What's the common denominator between 3 and 2? Or at least common multiple, I guess, rather, is what I should say. And that's 6. Now, how would I get from 3 to 6? I would multiply it by 2. So equation 1, we're going to multiply it by 2. And then equation 2, I want to get the 2y also to a 6 because I want it to match. So I'm going to multiply that by a 3. You'll notice that each one multiplied by the coefficient, which is the number in front of the other equation, right? So this one multiplied by the 2, and this one multiplied by the 3. That's not a fluke. That will always work. But you could always try to figure it out. So we actually do it now. So we're going to get, so we multiply everything by 2. 4 times 2 is 8. 3 times 2 is 6y. 34 times 2, people often forget to multiply the other side as well, is going to be 68. And then we're going to go multiply this equation by 3. So 5 times 3 is 15x, minus 2 times 3 is minus 6y, and 31 times 3 is 93. So now it looks like we can add this together a bit better. So this is equation 3 and this is equation 4, and I can add up 3 and 4 actually. So I'm going to add up equation 3 and I'm going to add up equation 4. 8 plus 15 is 23x. 6 plus minus 6 is plus 0y. So yay, that one got eliminated. And this is going to be equal to 1,561. Right, so then we get 23x equals 161. Divide both sides by 23. And you get x equals 7. Now we can actually plug this one into equation 1 or equation 2 or equation 3 or equation 4. It doesn't actually matter. All right, so I'm going to go x equals 7 into equation 1 because why not? So equation 1 is 4x plus 3y equals 34. Let me plug in the 7 for the x. Plus 3y equals 34. 28 plus 3y equals 34. So we get 3y equals 34 minus 28. 3y equals 6. And divide both sides by 3. And we get y equals 2. And we're done. So what we have is we have, therefore, solution to the linear system is x equals 7 and y equals 2. And that's that.